Alright, we're almost done with these additional examples. This should be the second to the last one. We have a mass falls from a height y equals h above the top of a spring oriented vertically. The mass hits the spring and eventually slows down to a stop. When the end of the spring reaches some y value, y equals negative d, when does the mass move fastest? So here I'll draw a picture of the setup. The block starts at some height h above our y equals 0, where it makes contact with the spring. As soon as it makes contact with the spring, or not as soon, basically it makes contact with the spring, moves downward, the spring starts compressing, and then eventually the block comes to a stop when the spring is stretched, or sorry, not stretched, when the spring is compressed to some y value of negative d. So here y is equal to negative d, and up here y is equal to h, and it's all in reference to this y equals 0. Okay, let's start. So to figure out when the mass is moving the fastest, here actually helps to take a look at the sum of the forces. We can think about, let's think energy first. So when we start at this point here, all our energy is mgh. So basically all potential energy. And then when we get to this point, so one thing I want to make you just wary of, we've defined y equals 0 here, but this block can continue to gain potential energy, or not gain, but this block can continue to convert its potential energy into kinetic energy up to this point y equals d. So if it's helpful to you to redefine your coordinate system such that this point here is y equals, this point here is y equals 0, this point therefore will be y equals d, and this top point will equal y equals h plus d. That's perfectly fine. So when we start all the way up here with respect to the lowest point this block goes to, we have all our energy stored in gravitational potential energy as mg h plus d. Then as this block starts to fall, that potential energy, some of that potential energy starts getting converted into kinetic energy. So by the time we get to this point here, the total energy is mgd, because it's still some height off its lowest point, plus some 1/2 mv squared. And none of the energy is in spring potential. And then when we get to this bottom point here, all our energy is stored in spring potential, which is 1/2 kx squared. And then at some intermediate point here, we're going to have some potential, gravitational potential, we're going to have some kinetic energy, and we're going to have some 1/2 kx squared. And at the final point, that x, the amount of compression is actually d, so 1/2 kd squared. So we know we want to maximize our kinetic energy for this thing to be moving the fastest. For this particular example, it actually helps to take a look at the sum of the forces acting on this block and ask, what's the acceleration of the block? Because basically, as long as the block is accelerating in the downward direction, it's getting faster and faster. At some point, it's going to start accelerating in the upward direction, meaning it'll start slowing down. The point where it goes from a downward acceleration to upward acceleration, that turning point of basically net acceleration 0, is the point where we get to move the fastest. So that's what we want to figure out. Drawing a free body diagram of the block somewhere from here to here, the only force acting on it is Fg, meaning the overall acceleration of this block is downward, so it's speeding up. Then when we get to a point here, the only force is still force of gravity, but now let's consider a point where we have the spring is being compressed some amount. So when it's being compressed some amount, we have force of gravity still acting downward, but then we have the spring force acting upward on it. And basically, as the spring compresses more and more, this spring force gets larger and larger. And the point where the spring force is actually equal to the force of gravity, that's pretty much up to the point where this block keeps accelerating and speeding up in the downward direction. The moment the spring force becomes larger than the force of gravity, the overall acceleration is now in the upward direction, meaning it's decelerating and slowing down. So at a point somewhere between this point where they've called y equals 0 to some point y equals negative d is where it's going to be moving the fastest. And in your homework problems, you'll actually calculate what this point is. For an example, where a mass slides down a slope like this. So it starts somewhere up here, it slides down a slope with friction, and you're being asked about when is it moving the fastest. And to find that, you're going to find when, in this case, you would find when is the force of gravity equal to the spring force. And then in the case here, you'll do a similar analysis of all the forces acting on it. And at some point, the sum of that forces goes to 0. And that's when that's where the situation changes from accelerating in this direction to then accelerating in that direction and slowing down.